Yo, what up, fam? Let's get back at this page. Yeah, you remember this page. The law of conservation of matter. Or wait, is it mass or matter? I asked you to change it, but you know what? The more I think about it, matter has mass. And if something has mass, then it is matter. So we could even say this is the law of conservation of mass. Look at that, just switching it back and forth. But as you remember, last time you left some extra room on a page that was your law of conservation of mass page. Let's go down to this blank page and let's fill it in with some awesome chemistry, blow your mind knowledge. Let's do this. So we'll skim past the things that we already discussed, like matter cannot be created or destroyed. It will only be converted from one form to another. And the fact that during a chemical reaction, the amount of each element must be the same in the starting reactants and in the final products. So we use vinegar and baking soda as our example. We saw that on the reactant side, there were 3 carbons, 5 hydrogens, 5 oxygens, and 1 sodium. And then when it went into the products, we ended up with the same exact number of atoms over there on that side too, because you can't lose any, you can't gain any. And I ask you to leave some room because we'll come back to this page. So here we are. We're back at this page. So now we need to record, we're going to record the reaction that we observed with the hydrogen peroxide and the Elefante toothpaste. So an elephant toothpaste, it's actually a pretty simple chemical formula. We have H2O2, which is the chemical formula for hydrogen peroxide. And the hydrogen peroxide, this is an example of a reaction, see if you can guess it before I tell you, where it splits into H2O and oxygen. Now, when it splits into those two, this means that this, if you remember those types of chemical reactions, or if you haven't seen it yet, is an example of a decomposition reaction.
Yo, yo.
Hello, me in the future.
Yo.
Little shout out from some science folks, some scientists from the classroom headed inside from 5th period. But let's look at this. Hydrogen peroxide in elephant toothpaste goes through a decomposition reaction, meaning that it decomposes into 2 molecules. It was 1 molecule, now it's 2 molecules. We have water plus oxygen. But as we're talking here about the law of conservation of matter, or mass, or matter, we need to kind of see what we have, what we're working with, what elements are we working with. So if we look at the elements that we have on our product side, remember our products are over here. So on our product side, we have hydrogen, which is H. We have oxygen, which is O. So we have hydrogen and oxygen. If we count the number of hydrogen that we have 2 hydrogens in the reactants. And we have 2 oxygens in the reactants as well. Okay, let's look at the products. In the products, we have 2 hydrogen. Oxygen, we have 3 oxygen. So where the heck did that extra oxygen come from? Well, it didn't come from anywhere, because actually this is not an accurate equation that I put up there. The reason it's not accurate is because when hydrogen peroxide decomposes, it doesn't just decompose into 1 water molecule and 1 oxygen molecule. It's not so simple as that. So actually what's happening is that, first off, you can't just have 1 hydrogen peroxide molecule go into water and oxygen. You actually have to start with 2 if you end up with water and oxygen. And so when you have 2 hydrogen peroxides, it ends up changing our numbers here. So in order to change these numbers, so we got, let's see, 2 in front means we have 2 times 2. So if we have 2 hydrogen peroxide molecules, then that means we have 2 of these. So it'd be 2 times 2 is 4. So now we have 4 hydrogens. And if we look at the oxygens, we have 2 oxygen molecules. And there's 2 oxygen atoms in an oxygen molecule. So we do 2 times 2 again. So we actually have 4 oxygens, not 2. All right, well, let's go over to the right side. If we start with 4 hydrogens, we need to end with 4 hydrogens. So we need to figure out, how can I get 4 hydrogens if I only have 2 here? Well, I can make sure I have 2 water molecules. If I have 2 water molecules, now I can take, since this would be O1, I can say I have 1 oxygen atom in one water molecule. But if I multiply it times 2, now I have 2 oxygens plus these 2 oxygens over here, and that equals 4. So now in my products, I have 4 hydrogens, 4 oxygens. In my reactants, I have 4 hydrogens and 4 oxygens. So this is something that we call stoichiometry. 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 This is something that we call stoichiometry, which means that we balance it out so that the reaction has the same number of atoms on the left side as it does on the right side, because in nature, matter or mass or matter cannot be created or destroyed. It will only be transferred from one form to another. So in order for this reaction to occur, you have to have 2 hydrogen peroxides. And when you do, you end up making 2 water molecules and 1 oxygen molecule. And that's how the reaction occurs. That means that it's balanced on each side. So sometimes you don't have to balance it because the equation already has the correct number of atoms on each side, and it happens easily. When you do have to balance it, sometimes you actually have to add a catalyst like we did here when we added the yeast, to allow that reaction to occur. So look critically at your chemical formulas. Think, are there the correct number of atoms on the left side, reactant side, as there is on the product side? And if there's not, do some balancing, yo. You can do it. Check it out. Think about exponents. Think about math class. Science and math, they are one basically. You get it. All right, guys and gals and everyone else. Happy times being a scientist out there. Be observant. Adios, amigos.